Using STL or standard data structures without knowing time complexity is like driving blindly. By the end of this video, you will completely understand time complexity of standard data structures and all the functions that we mostly use in STL. So let's get started. So the most important is dynamic array, which is vector. There are 4 functions that we use widely, that is push, pop, insert and erase. Pushback pushes the data at the end of the array, right? That takes O of 1 time. That means it's a constant time operation. Irrespective of what length of vector is, you can push the data at the end with constant amount of time. Pop back also takes constant amount of time. That means whatever the total number of elements in vector is, it doesn't matter for us. You can directly remove the last element from the vector and it's going to take constant amount of time. Insert and erase is another story. Let's say you are inserting somewhere in the middle, not at the end. For end we have pushback, right? But you are inserting somewhere in the middle. That is going to take O of n time in worst case scenario. Same goes for erase as well. You are not erasing or removing the last element, rather you are doing it somewhere in between. That is going to take O of n time in worst case scenario, right? Let's look at priority queue. To understand how exactly priority queue works, I highly recommend that you watch heap data structure video first. I will put that into the cards. Also, I highly recommend that you watch heap sort algorithm as well. So these 3 are the main operations that we perform on priority queue. Push takes log n time. Pop exactly same, log n time. Fetching the largest value is going to take O of 1 time, that is constant amount of time. If you have gone through my heap data structure video, then you know that we always store the max value at the root. That's why it takes O of n time. All the other operations like insert, that is push, and pop actually takes log n time because of rearrangements. After that, we have a very popular data structure called as set. Set has mainly 3 different operations. First is insert, erase and find. Putting an element into set, removing it and finding to check whether that element is present or not. All 3 of them takes log n time. If you want to understand how exactly it takes log n time for all the 3 operations, well, you need to know that set stores the data in form of tree. And tree is a balanced tree. That means whenever you erase or insert data into that set, it rebalances and follows some properties, so that every single time you perform any type of operation, whether it's insert or erase, it's going to take log n time. If you want me to teach how exactly set works and how exactly it stores the data into the memory, please do comment. I will make another video explaining how exactly the set works. We have already made a video how exactly priority queue works. We can also go through a separate video on how exactly set works. There is something called unordered set as well. Now unordered set uses hash to store the data, to erase and to find. That's why it takes constant amount of time for all the 3 operations. But in worst case scenario, in scenario of collision, it takes O of n time. Let's say there are n elements and hash for all of them is surprisingly equal. Then all of them will be stored under the same hash, correct? Let's say you want to insert a new element. Now this new element is also generating a hash that is exactly same as other n elements that are already present in unordered set. Then this new element must be inserted under the same hash code, correct? And that takes O of n time in worst case scenario. Otherwise, all 3 operations are just going to take constant amount of time. Same thing goes for the map as well. As we have seen for the set, there is something called set and there is something called unordered set. Similarly for map, we have a map and we have unordered map. Map is going to store the data into memory. Similarly, that we store data in memory for set, right? It will use some kind of tree. If you want, I can make another video explaining how exactly map stores the data into the memory. But it also uses some kind of tree that rebalances once you erase the data or insert the data. That rebalancing follows some properties so that every single time you insert data, it will take log n time, and every single time you erase data, it takes log n time. Same goes for find as well. Now in unordered map, it takes constant amount of time to perform any operation. Why? Because unordered map also uses hash. Whenever you want to insert a new element into unordered map, it will generate hash of it and stores the data into memory. Let's say, for some reason, unfortunately, there are n elements already present inside unordered map and all of them have generated exact same hash. So they all must be under exact same hash, correct? And now this new element will also go there because it's also generating the exact same hash, unfortunately. So what will happen? Now you have to insert this new element into the existing one. The existing length is already n. So it's going to take O of n time in worst case scenario. That is very rare. So mostly this insert, erase and find takes constant amount of time in unordered map because of hashing. I can deeply discuss how exactly set, map, unordered map and unordered set stores the data into the memory. If you want that, please do comment. I will make another video. Now let's go to the stack and queue. Very popular. Stack and queue mostly used for push and pop operations only. The only difference is that in stack you put the data and while fetching you fetch from the top, and now in queue you push the data and you take out the data. So push takes constant amount of time and pop also takes constant amount of time. This front operation is applicable for queue because in queue you are going to push the data and you are going to fetch the data from the beginning, while in stack you push the data and you pop the latest data from the stack, right? You need to have complete understanding on how exactly all these data structures work. It's not just about C++. In all the other programming languages like Java, Python, you have exactly same data structures and they follow almost exactly the same time complexity rules as well. So let's do a recap. We need to focus on key operations where it takes large amount of time. Like in vector, in insert and erase, it's going to take O of n time. So we are not going to do it. We need to avoid. Now in priority queue everything is log n, so no problem there. Same thing goes for set and map as well. You can speed up the process by using unordered set and unordered map because it takes constant amount of time. In 99% of the time you can use set and map. To speed up the process, you can use unordered set and unordered map. Log n also works, but constant amount of time is much better than log n. You can use it for speeding up the process.